Imagine waking up tomorrow. The sun seems bigger, not dramatically, but noticeably. Weather forecasts are wrong. Satellites start acting strange. Birds migrate in wrong directions. Over the next few hours, temperatures rise by 2, then 5, then 10 degrees Celsius. This is not science fiction. This is the reality of our star. The sun moved just 1 single kilometer closer to Earth. 1 kilometer. That's the length of 10 football fields. In cosmic terms, it's less than a hair on a giant's head. The sun is 150 million kilometers away. 1 kilometer closer is a change of 0.000000067%. Tiny, insignificant, and yet enough to end civilization as we know it. In this video, we'll explore the cascade of disasters, from orbital mechanics to boiling oceans, from dead satellites to roasted crops. And we'll ask the big question: how fragile is our pale blue dot really? Think of the Earth as a perfect marble spinning on a flat table, and the sun is a bowling ball sitting nearby, pulling the marble with an invisible rope, gravity. That rope is exactly the right length for the marble to spin in a circle without falling in or flying away. Now move the bowling ball 1 millimeter closer. The marble's path changes. Not much at first, but after a few spins, the marble starts to wobble. After 1,000 spins, it spirals inward. This is the dance of gravity. The sun's gravitational pull increases with the square of the distance. When the sun gets 1 km closer, the pull increases by a tiny fraction, 0.0000013%. That sounds like nothing, but on a planetary scale, nothing becomes everything. The Earth's orbit is not a perfect circle. It's an ellipse. We are already 5 million kilometers closer to the sun in January than in July. And we survive. So what's an extra kilometer? The problem is not the kilometer itself. It's the instability. Like a chair that's perfectly balanced on 3 legs. Removing 1 millimeter from one leg won't make it fall immediately. But the first small vibration, and it crashes. Let's get specific. 1 kilometer closer means the average solar radiation reaching Earth increases by about 1.36 watts per square meter. That doesn't sound like much, but multiply that by the entire surface area of Earth, 510 trillion square meters. That's an extra 693 quadrillion watts of energy. Every second, that's the equivalent of 10,000 Hiroshima atomic bombs. Every single day. What happens to this energy? First, the oceans absorb it. Sea surface temperatures rise by 0.5 degrees C in the first month. That triggers super hurricanes, Category 6 or 7, winds over 300 km/h. Second, the polar ice caps melt faster. Not in decades, in months. Sea levels rise by 10 meters in the first year. Amsterdam, Miami, Shanghai gone. Third, the atmosphere expands. Satellites in low Earth orbit, like the ISS, experience drag. Their orbits decay. Within 6 months, most satellites crash back to Earth. No GPS, no internet, no weather forecasts. Fourth, the greenhouse effect amplifies everything. Warmer oceans release more CO2 and methane. Temperatures keep climbing. Within 2 years, the average global temperature reaches 80 degrees C. The last time Earth was this hot, it was the Permian-Triassic extinction event. 90% of all species died. But that change took millions of years. This takes 2. But what about us? Humans. We've survived ice ages, supervolcanoes, asteroid impacts. Can we survive a sun that's 1 km closer? The short answer, maybe. But not 7 billion of us. Within the first year, agriculture collapses. Crops cannot grow at 50 degrees C. The soil dries out. Pollinators die. The world's food supply vanishes. Famine kills 90% of the population. The remaining 10%, around 700 million people, would have to live underground or in deep caves, where the temperature is stable. They would rely on geothermal energy and synthetic food grown under LED lights. But here's the cruel irony. The only places that remain habitable are the poles, Antarctica and the Arctic. But those are also the first places to be fought over by the remaining militaries. Nuclear war becomes inevitable. This thought experiment isn't about predicting the future. It's about understanding our present. We are already changing Earth's temperature by burning fossil fuels. We've already added 2 degrees C. That's like moving the sun 200,000 kilometers closer in terms of energy. We are doing to ourselves slowly what a 1 km sun shift would do instantly. So what's the final answer? Would a 1 km closer sun destroy us? Yes, not because 1 km is large, but because our existence is balanced on a knife's edge. The habitable zone, the region around a star where water can be liquid, is very narrow. Earth is right in the middle. Venus, just 40 million km closer, is a hellish 460 degrees C. Mars, 50 million km farther, is a frozen desert. We live on a razor's edge. The beauty of this thought experiment is that it reminds us. We are not masters of the universe. We are passengers on a spaceship called Earth, flying through a cosmos that doesn't care about us. 1 kilometer. That's all it takes. But here's the hopeful part. We have the power to move our own planet. Not physically, but thermally. By stopping climate change, we are effectively pushing the sun back. Every fraction of a degree we prevent is a kilometer of safety we gain. So the next time you look up at the sun, remember it's exactly where it should be. And it's up to us to keep it that way. If you made it this far, you're exactly the kind of curious mind we make these videos for. Hit subscribe, it's free, and it helps us dig deeper into questions like this one. Did this video change how you think about Earth's fragility? Answer with yes or no in the comments. Thanks for watching.